right, so you've already done some work around conceptually what Social Security and Medicare tax are, and now we're going to use that as a way into looking at some percentage calculations. So remember, Social Security is an employee-employer shared tax, meaning that both sides are paying the same amount into Social Security. And that amount is that each one, the employee and the employer, pay $6.20 for every $100 earned by the employee. I want you to think just for a minute about what that means. So if the employee pays $6.20, or the employer, for every $100 earned, how much would the employee and the employer pay if there were $200 earned? What about $300? What about $1,000? And then I want you to think in the other direction in terms of division. What if the employee only earned $50? What if the employee earned $1? And I want you to keep in mind when we're looking at this, that important relationship, that inverse relationship between multiplication and division. So we'll come back to that. So just a little visual. So for every $100 earned, the payment is going to be $6.20, and you could even picture that kind of in groups. So every time I have one of these, that amount is going to come out. So let's look at an example. So we have Renee, and she makes $4,673 in a month, which means she's going to pay $6.20. Here's the Social Security for every $100 earned. And then you want to think about, well, how many times is she earning $100? And that's going to tell you the total amount that she's going to pay. So what you want to do is you want to take her total and divide it into groups of $100. It's like, how many times can I take this and divide it into $100 groups? And you're going to pay $6.20, or she's going to pay $6.20 for each one of those groups. So if I take 4,673 and divide it into $100 groups, I can do that 46.73 times. So she's going to pay this much. So she's going to pay this amount 46.73 times, which is what multiplication means. And she's going to pay $289.73. And so is her employer. So thinking about things in terms of $100 earned, it might be a little bit simpler to think about, well, how much is she paying for every $1? Because she doesn't always, as we saw in this example, you couldn't divide her earnings up by 100 into nice little whole amounts here. We got this decimal amount. But instead, if we think in terms of dollars, and basically by doing that, we're just doing that division by 100. We're just doing the division ahead of time before we do the multiplication. And we have the equal sign here. This is the idea of equivalent or equal math statements or math ideas. So if she is going to pay $6.20 for every $100, that's the same as saying she's going to pay a little more than 6 cents in tax for every dollar earned. And I encouraged you before to think about this in terms of division, which is what this line means right here. So we're just doing the division ahead of time. So if I take that $6.20 and I divide it ahead of time by the 100, This is how much per 100. This is how much per $1. So I have this kind of cool unit here, a unit rate, and this is the amount paid per $1. So if she only made $2, which would be kind of funny, I would just take this and multiply it by 2. So let's say she made $2, and I want to know how much Social Security tax she's going to pay. So she would pay a little over 12 cents. Or let's say she made $30. So we've got 0.062 cents for every dollar, and she's going to make $30. She'd pay $1.86 in Social Security tax. So we're going to use this $1 unit, this unit rate, instead of per 100, and that'll make things a little bit simpler. Okay, so remember that $6.20 for every 100 is equal to a little over 6 cents for every dollar earned. And so when we have this earning amount, this is a different person who made $3,566. And so all we're going to do is we're going to take our unit rate of 0.062, which is the amount for $1, and we're going to multiply that by 3,566. And I want to think about why we're doing that. If this is the amount made per dollar, and this is the number of dollars made, then this person is going to pay this amount 3,566 times, which is exactly what multiplication allows us to do, is to say I have this amount, 0.062, a little over 6 cents, and I'm going to pay that amount 3,566 times because that's how many dollars I earned. And so that's going to be 221. And up here you can see, because this is less than 4, we went ahead and just rounded that down. And that would be the amount of Social Security tax paid by the employee or the employer, depending on which side you're looking at. And now we can go back to those T-tables that we've already seen because we have a product relationship. Here's our multiplication, and we have a product relationship. Which is cool because now we can use something familiar to visualize what's happening here. So the product is going to be the total tax. And we just saw if we have the tax paid per dollar, which is this amount right here, and the number of dollars earned, which is right here, and I multiplied those by each other, it gave me the total tax, which shows me that I have the same kind of multiplication and division inverse relationship. If this is the total tax, and I divide by the amount paid per dollar, then that's going to give me the total amount made. Or if I take the tax and I divide by the total amount made, that's going to give me the amount I'm paying per dollar. And we have a few extra decimals, and that's okay. It's just because we're doing some rounding in places, but you can see the values are very close. And so remember, we have this relationship where if this is multiplication, then I can use the inverse relationships and think about division in either one of these directions. All right, so keep that in mind. And we'll do a practice problem. So I encourage you to go ahead and pause this, and then we'll take a look at this together. All right, so in this one I can see that I'm missing the total tax. That's what we're looking for. So I just need to use this product relationship of multiplication. And now we're going to look in terms instead of Medicare. So we were looking at Social Security, but now we're going to look at Medicare. Dentally Dental pays Medicare tax to the federal government at a tax rate of $1.45 for every $100 their employees earn. So in this one, when we were looking at Social Security, this was $6.20 for every 100, or a little over 6 cents for every dollar. So we can use that same idea looking at Medicare, but now instead of $6.20 for every 100, it's $1.45 for every 100. So then if I think about what this means, if it's $1.45 for every $100 earned, that's equal to $0.0145, so just a little over 1 cent for every dollar, and that's going to be the unit per dollar that we're going to work with for Medicare. And remember, all we're doing is doing the division ahead of time so that we're not working in units of 100, we're working in units of $1. So Marcella works as a dental hygienist at Dentally Dental. She earned $67,000, or she did earn $67,900 last year. How much Medicare tax did Dentally Dental pay to the government last year for Marcella's earnings? So Medicare, like Social Security, is something where both the employee and the employer are paying. And so all we need to do is say this is how much they're paying per dollar, and this is how many dollars. And so really they paid $0.0145 67,900 times. So our product relationship just says I'm going to take the amount per dollar and multiply it 67,900, and that means they paid $984.55 in Medicare for Marcella. And then I can use the inverse relationship to check and make sure that makes sense. So remember, this is a product, so if I go in this direction and divide, I should get this. So let's check. So I'm going to take that total tax amount that I got and divide by 0.0145, 0.0145, and I get 67,900. Or if I do it in the other direction, 984.55, and I divide by the total amount that she earned, then we get that tax rate back out of it. So keep in mind that really important relationship between multiplication and division, and picture it in that T table, because that's really going to help. All right, we have another practice question here. So go ahead and pause it, and I want you to notice really quickly first that in this case we have the product and we have the amount per dollar that is being paid in Medicare tax, but we don't have the amount the employee earned. So go ahead and just pause it, take a look, and then when you're ready to check, go ahead and unpause it. All right, so we already know that $1.45 per 100 is equivalent to 0.0145 if we're talking about amount paid per dollar, per $1. And then we can just use that inverse relationship and picture it in the T table to figure out what was the annual income when $984.55 was paid. And actually, we're looking at the same amounts here, And so this is that 67,900 that we were working with before. All right, so let's take this and let's talk about percentages and just apply some vocabulary here. So we already looked, this is for Social Security. If we were paying $6.20 for every $100, we could also say that we were paying 6.2 parts of every 100 that was made. So if I make 100, I'm taking 6.2 parts of every 100 out. And these words of and per, we're talking about for each 100. And per, let's look at that. Per is for each. And think about the word cent. How many cents are there in a dollar? There's 100. How many years are there in a century? There's 100. Cent means 100. And so per cent, or when we're talking about percentages, we're just talking about for every 100. So to say $6.20 for every 100 is the same thing as saying 6.2%. And all this symbol is doing is replacing this over here. Just means 6.2 for each 100. And that's what a percentage is. 6.2% is equivalent to 6.2 parts out of 100. And if we break that down into the dollar unit like we did before, that's equal to 0.062 parts out of 1, and that's the same as saying 6.2 divided by 100. So when we're talking about percentages, we're just talking about things out of 100. And here's that familiar T-table, and we're just going to add some vocabulary here. So when we were looking at this previous example, where we had the product relationship, and we had the total tax paid, and we had the amount per dollar and the amount made, this is specific to Medicare tax. But taxes are a percentage, so we can take this and make it more general, and we can just look at the part, the whole, the percent. So remember, in the last example, the part was the part of the income paid in, that was Social Security tax that time. So what part of the income was paid in Social Security tax? The whole, or the whole thing, was how much were the total earnings. So the whole thing, all of it. And then the percentage, remember the percentage is parts out of 100, but to simplify it, we're going to show it as parts per 1, just like we did with Social Security when we took $6.20 and we simplified that to 0.62 for every dollar. And it just makes the calculations a little bit easier. So we have this T-table relationship, and remember when we're looking in this direction, since it's a product, we're thinking about multiplication, but if we go in this direction, we're thinking about the inverse of division. So now we have this cool little tool, and we can set it up to find anything that we're missing. So let's take a look. Igor is saving 5% of his net income each month for a laptop. Okay, so now we're moving away from thinking about percentages just as taxes, and we're going to just think about percentages of whole amounts. So 5% of his net income, and net is income after all deductions, and an easy way to think about this is take home pay. So after all the stuff gets taken out, he's taking home $3,200, and he's saving 5% of that income for a laptop, and he's doing that monthly, I guess. So how much of Igor's monthly income is he saving each month for this laptop? So let's see, what do we know? We know the percentage, and we know total income. So if we look back at the T-table relationships that we have here, we're looking for the part that Igor's saving. We know the percentage, and we know the whole. So right now, this is the part we're looking for, and that'll be the part saved. And we know that the percentage is 5%, and we're going to show that instead of parts out of 100, we're going to show that as parts out of $1. So I'm going to take the 5 and divide it by 100, and that's 0.05, which means that Igor is saving 5 cents per dollar for the laptop. And the total income, the take-home income, is $3,200. And then we just need to use this product relationship. So I'm going to take, for every dollar, Igor is saving 5 cents. So 5 cents out of every dollar, and he's going to do that 3,200 times. So on this paycheck, so let's look at, we've got product, percentage, and whole. So 5 cents out of every dollar, and dollars earned 3,200. And when I do that multiplication, Igor's going to save $160 toward the laptop. And then I can always check it with the inverse relationships. If I take the $160 earned, sorry, so $160 saved, and divide it by the 5 cents out of every dollar, we can see that Igor earned $3,200. That was the take home. And we can use the inverse relationship in the other direction. If I have 160 and divide it by the total amount earned, that shows that Igor is saving 5 cents for every dollar. Okay, so I want you to pause here and make sure you're really comfortable on this relationship, and then in the next video we're going to take a look at some more examples. You can preview the percentages handout, so feel free to try those ahead of time, and then come back for the second part of the lecture to look at the percentages examples.